Hey guys, this is Joe East here. I got a lot of inquiries from friends and colleagues about artificial intelligence, and I want to do a series of talks on artificial intelligence and what it is and what it is not, and my position that artificial intelligence is a delusion of propaganda. It does not really exist, although it looks like magic to the uninitiated and those who might not understand computers. Computers are not intelligent. There's no such thing as artificial intelligence. They're machines. They do what they're told and only what they're told. They cannot create anything new. So we're going to get into the details of how computers are structured and how they cannot be creative is kind of the conclusion I want to show you guys. Just by going through some basics of architecture, and hopefully I don't delve too deep into the technicals here where the layman, hopefully you laymen can understand this if you're a non-technical person. I hope this is simple enough. Send me some feedback in the comments if you guys need some clarification here. Okay, computer architecture basics. So the computer is based on the concept of a switch. First diagram here. So a light switch is the same thing as the switches in your computer. They're either on or they're off, and there's a control mechanism. So it's basically a circuit is either activated or not activated. It's on or it's off. Basics, very, very basic stuff. It's commonly called a transistor within a computer. However, the difference between, say, your light switch and the transistors in a computer is that the transistors within your computer, you can have millions and billions of switches to use and to configure in the different configurations and get some interesting functions out of these millions or billions of switches. But ultimately, a computer is based on a switch. A circuit is either on or off. And use your imagination. Can a switch be creative? The answer is no. However, somebody can give it instructions to where it might look like it's creative. So human beings can make it do some very amazing things because it's a machine. Okay, two states of the switch. It's either on or off. There's no in between in the computer architecture. Now, we as specialists in computers know there's also undetermined states, but that's not for the layman to know. That's for specialists to figure out how to deal with the indeterminate states. But for operational purposes and computational purposes, the switches are all either on or off. You combine the switches in a certain way and you get something called OR gates and AND gates. And the English word OR and the English word AND is roughly approximating what these gates do and with the inputs for an AND function and the inputs for an OR function gives particular outputs. You guys want to know more about gates, just do a search on this, AND gates and OR gates, and you can get into the truth table of the opposite, the negative of these gates, like the NAND gate and the NOR gate. But essentially, there's two types of gates and their negative equivalents, AND gate and OR gate. Specialists can dig into the details. A computer with the concept of these switches here and these gates here can only do three functions. A computer is only capable of three functions based on this architecture. The first function is logical operations. So an AND gate and an OR gate can perform strictly logical operations. Sometimes in the trade it's called Boolean logic. If, then, else is another way of saying in code language. So it can perform logical operations and strict, very, very strict logical operations. With very little deviation from these rules of Boolean logic. The second one is mathematical operations. So you can arrange these gates to be adding the inputs, and the output gives you the sum, or multiplication of the inputs, giving you the output functions, or dividing, add, subtraction, multiplication, dividing. And if you can stack these together, you can do some calculus, integrals or whatever. Mathematical operations. It's all based on these gates and these switches. Everything I'm talking to you about must be based on gates and switches, which is fundamentals of computer architecture. And the third thing it does is storage of symbols. So you can arrange these gates in feedback loops that causes it to store what we call symbols. Again, it's storing essentially is a switch on or is a switch off? Or is this sequence of 8 switches? This one's on, that one's off, that one's on, that one's on, that one's on, that one's off, that one's off. Series of 8 switches stores that in some way. It could be on transistor storage, it could be on hard disk storage, magnetic, CD-ROM, DVD-ROM, whatever. But as long as you have a storage device that's capable of 2 states of on and off, you can store all this computer stuff, all this symbolic data. And these symbols can be converted into different things based on the logical operators. For example, one string of 8 switches means the letter A. Another string of switches means the letter B. Another string of switches means the letter C, D, F, and so on and so forth. So we can assign these symbols to mean certain keys on a keyboard or whatever we want to. There's standards out there. Look, if you want to dig into the details of symbols represented in switch configurations, look up something called ASCII code. ASCII. ASCII is a good place to start, just so you can get the rough basics of what this stuff does. The basics of artificial intelligence. The basics of artificial intelligence. So on this side in blue, I'm going to show you how the very basic of artificial intelligence works and how the very basics of just about every piece of artificial intelligence works. Let's say you have 10 pieces of information here and 10 pieces of information here. You want to put all these 10 pieces of information and call it an array or a section of your data. And you want to put these 10 pieces of information in, say, another array, array A and array B. I want to compare these 2 arrays of data or symbols or whatever the hell is in there. And then I perform an operation on these 2 arrays called a correlation coefficient. So I want to see how related these 2 pieces of data arrays are related to each other. And out pops, oh, they're 80% correlated. So it got 80% of something in common. So that's how we come by with 80% correlations. So computers can do this very well. It's basically a logical operation combined with a mathematical operation. So the mathematical operation, it compares each data set together and it says yes or no, does it compare? And then it does a mathematical operation, how many compare, add it up and tells you, oh, 80% of both of these data sets agree or whatever, or similar or whatever, however you want to set up the logical operators. Again, it's a mathematical operation, a logical operation, and a data storage operation. Is the only 3 things a computer can do. If you want to play around with this operation, you can go to Excel and use the correl function. If you have 2 data sets in your spreadsheet of say 1 column here, 1 column there, and you want to perform this correlation operation, you use correl and then open parentheses, that first array colon and the second array B. Like I said, go do searches on this stuff if you want to set up this. You can probably set it up, even if you're a rookie, you can probably set this up within about 5 or 10 minutes. Pretty easy to kind of play around with. So that is basic artificial intelligence, very like the core of artificial intelligence, the way all these companies, when you see ads pop up and you say, how do they know I would like that? Well, let's say array A is Jack and array B is Jane. And let's say there's 1 million pieces of information in each one of these arrays of 10 years of Jack and Jane ordering shit online, right? Okay, so you correlate the array Jack and Jane and see how close their purchasing patterns are. If they're 80% similar, well, whatever Jack buys, you might want to market to Jane, maybe. Or you take a piece of Jack and Jane's data set, say, oh, Jack's a policeman. Jane is a policeman. Oh, they both have purchased, I don't know, guns or armor protection or something, equipment or whatever police do, right? Or if they're school teachers, oh, they purchase paper or pencils or something. And then so you look for all teachers or all cops, and you market, say, guns to cops, certain type of guns, because say if 80% purchase this type of gun, well, you might want to market guns to them. Or school teachers, 90% of school teachers like this type of paper. Okay, I'm going to market them this type of paper and try to sell it to the rest of them who haven't been marketed to. So that's another way that is a way of using these correlation coefficients of the data sets of the arrays. That's basic artificial intelligence. That's what all these marketing, advertising you see pop up, automated or whatever. Every once in a while, you might say, well, I'm not interested in that. Well, the reason is because it might be 80% right and you're taking a chance, marketing it to you, and they've made not a mistake, but chances are that 20% of what they market to you won't be irrelevant, but they still make a good bit of cash because they use 80% of stuff that you like, that you're interested in, based on your profile of these two arrays of your purchasing habits and say the past 10, 20, 30, whatever years you've been online with these people, or whatever data they can gather on you, right? So thus, Facebook and Google and the rest of these companies, oh my God, their information they're trying to collect on you, they'll probably be pretty fanatical about it. Why? Because these arrays are very important to see how they correlate to your spending habits, or spending habits of other people similar to you, and then market to you. If they don't know your spending habits, we'll look at people who exist in the same demographic as you, and then market to you the same thing that they purchased. That's basic artificial intelligence. That's why you got more and more companies looking for data storage, cloud storage, or whatever. They want massive pieces of data on you so they can market this to you based on these basic equations. And the application of the equations might be a bit more sophisticated than what I'm telling you, but essentially this is the idea. You just basically drill down into this to a more sophisticated model, or a more logical operations, more mathematical operations, more data storage operations, using these basic correlation coefficients to figure out how to market things to you and patterns. Let's say you're also in Homeland Security and you're trying to predict behavior. Oh, well, you take all the purchasing patterns or the behavior patterns in these data arrays of all serial killers, all murderers, all, I don't know, whatever criminals you want to do, and then go look for all the people who are not murderers and criminals and whatever, and see if they have similar profiles. And so if you meet up with, say, a group of 10,000 people with 99% of the profile of murderers and robbers or terrorists or whatever the hell, and this correlation coefficient comes out to 99% profile, well then maybe the security guys are going to start taking a closer look at those guys. And that's another reason for this massive data collection thing in artificial intelligence, or so-called artificial intelligence. It's not really intelligence. It's essentially what I'm telling you here. It's really simple stuff once you get down and break it down into pieces. Okay, let's close this out here and we'll come back later. Thank you. Take care. Goodbye.